Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problem number 3 of the 2004 AP Calculus AP Release exams, focusing on position, velocity, and acceleration. All right, let's take a look at 3A. It says a particle moves along the y-axis so that its velocity v at time t greater than or equal to 0 is given by v of t equals 1 minus the arctan of e to the t. 1 minus the arctan of e to the t. At times t equals 0, the particle is at y equals -1. Note that arctan tan to the -1 is arctan. Question: find the acceleration of the particle at time t equals 0. All right, so before we start, we're going to take a look at the formula that's going to be guiding our problem solving process in this problem. So what's the connection between position and velocity? That's the question, and also acceleration, because we're looking for acceleration here. Now, this is a formula that you might be accustomed to. You have z-va, x, position, velocity, and acceleration. All right, if you are going from position to velocity, you take the first derivative with respect to time. And then from velocity to acceleration, you take another derivative with respect to time. Okay, so this basically tells us that acceleration is the what? Acceleration is the second derivative of position, d squared dt squared. Okay, if you're going from acceleration to velocity, you're going to be looking at, let's do that again. We're going to be looking at the inverse of differentiation, which is basically the integral of the acceleration function dt plus v sub 0. Okay, and then if you're going from velocity to position, you're looking at the integral of velocity dt plus the initial position x sub 0. Okay, all right, now in this problem, what we're dealing with is actually the movement along the y-axis. Okay, so the only alteration we're going to be making here is instead of x, we're going to be having y occupying this spot right here. Okay, all right, so the question asks us to find the acceleration of the particle at time t equals 0. So in other words, we're to find a of 2. A of t is the acceleration function. So what is the relationship between v and a? So if you look at our continuum here, from velocity to acceleration, you differentiate once. So your acceleration function is the derivative of your velocity function, or v prime of t, the same thing, okay? So in order to find a2, we're gonna basically be looking at what is the value of v prime of 2, evaluating the derivative of the velocity at time t equals 2. Okay, now this is a 2004 question, so the first 3 are calculator active questions, so we can use a calculator for this problem. But let's do a real quick review, okay? If you're doing this problem by hand, trying to find the acceleration at a particular time given the velocity function, there are 2 parts to it. Part 1, you have to find the acceleration function by differentiating your velocity function. After finding the acceleration function, you're done with the calculus. Now you do your arithmetic piece, which is to evaluate your acceleration at the indicated time, namely t equals 2. But with a calculator, you can do these 2 steps simultaneously. Okay, so with a calculator, with a calc, what you can do is you just simply plug in the derivative of the velocity function, all right, and you evaluate that expression at time t equals 2. Just plug this into a calculator, press enter, and you are done, okay? All right, so these are the sequence of steps we're going to follow. all right, the calculator steps. Just to make our life easy, what we'll do first is we're going to store the function, okay? We're going to store the function in the calculator. So we'll use it repeatedly for parts A, B, C, and D, okay? Store the function. You do this by typing in 1 minus the arctan of e to the t, all right? Just store it in v of t. And after storing the function, you want to differentiate and evaluate. Differentiate and evaluate simultaneously. So to do that, you just enter the command d of the velocity function in the differentiating with respect to t. Close that. So entering this will return the derivative of this function, but we want to evaluate it, okay, at t equals 2. So this is exactly what you enter into your calculator after storing this function in v of t, and it will give us the acceleration at t equals 2. Okay, so let's go ahead and start. We're going to go 1 minus the arctan, second function tan, or actually diamond tan. 1 minus the arctan of e to the t, close the exponent, close the inverse trigonometric function, store that in v of t, so alpha, where is v? Alpha 0, v of t. Enter. All right, the calculator says done. So let's just make sure that it has done exactly what we want. So I'm going to just enter v of t into my calculator, and hopefully it returns the function. Okay? Enter 1 minus arctan of e to the t. Perfect. It's always good to check your entry to make sure it's good, all right? So now what we're going to do is just compute the derivative. So the derivative, where is that? There you are, derivative of v of t, just call the v of t function. You differentiate in respect to t. So this will return the derivative expression, all right? But we want to evaluate it at, so you put the bar, evaluate it at t equals 2. Okay, enter. That's the exact answer. I need the approximate numerical result. Negative 1.32, negative 0.1329. All right, so let's write that down. Our acceleration, change the color, at times t equals 2a of 2, which is equal to v prime of 2, is 0.1329, negative 0.1329. So what's the scoring guidelines for this one? This is a 1-point problem. Just computing this will earn you exactly 1 point. All right, let's take a look at question number 3b. It says, is the speed of the particle increasing or decreasing at time t equals 2? Give a reason for your answer. Okay, so you gotta remember the rule concerning how to determine the behavior of the speed. So the rule for the determination of the behavior of the speed, increasing or decreasing, is as follows. All right, so the rule is if the velocity and acceleration, we're gonna split it into two, okay, just like a piecewise statement. If the velocity and acceleration, part 1, if they have the same sign, guess what? It's as though they're working together. So that means that the speed is going to be increasing, okay? Speed increasing. So if they're both positive, the speed is increasing and the particle is moving to the upward direction, sorry. If they're both negative, then the particle is speeding up. The speed is increasing in the downward direction. So that's same sign means speed is increasing. Different signs basically means that the speed is decreasing, okay? So the steps that we're going to follow are the following. Okay, so first of all, we're going to determine the sign of your acceleration and velocity. So determine the signs of velocity and acceleration at this particular time right here, t equals 2. So determine the sign of v of 2 and a of 2. And then step 2, compare. So you compare the signs and then use the rules to arrive at your conclusion. Okay? We already know from part A that a of 2 is equal to negative 0.1329. Okay? V of 2, we don't know what that is. So let's go ahead and determine what V of 2 is, 2 4 decimal places. So in our calculator, we already have V of t stored there. So what we're going to do is call it back up and change the input value to 2, okay? V of 2, enter. And then I need a numerical result. I'm going to enter negative 0.4363. So negative 0.4363. Okay, so what do we notice here? Their signs are the same. So if the signs are the same, what do we know about the behavior of the speed? The speed is going to be increasing, okay? So since velocity at 2 is less than 0 and the acceleration at t equals 2 is also less than 0, the signs are the same, which implies that the speed is doing what? The speed is increasing, okay? So this is just a side question. Do you think it's going up or down? Well, since the velocity is negative, that means it's going down. So it's speeding up in the downward direction along the y-axis, okay? All right, so this one, in order to get your full credit, you earn only 1 point. You just have to state that the speed is increasing and the reason why. Okay, so this is your reason that they both have the same sign, and this is your answer. So if you state the answer with your reason, you earn a total of 1 point. All right, let's take a look at part C. It says find the time t greater than or equal to 0 at which a particle reaches its highest point. Justify your answer. Okay, so what we're looking for here, we're going up and down. We want to find, see, where the particle, okay, find where y of t is equal to the maximum. Okay, find the point where y of t is the maximum. Now, in this case, well, let's be specific here. It's not just a relative maximum. We're looking for where y of t is the absolute maximum. Okay, so local and absolute or global maximas are different. In this case, we're looking for absolute maximum. Now, what's the rule for finding the absolute maximum? So let's go over the rule real quick. F of x has an absolute maximum at, let's say, an x value equals a if f of x, if f of a, so the function evaluated at that particular value, is equal to the maximum where a is a critical value, and or an endpoint. Sometimes the endpoint is going to be one of the critical values, okay? And then that could actually be your extrema, all right? Sometimes you have an overlap, sometimes you don't, and the endpoint is the absolute max. and sometimes it's just a critical value. All right. So in this situation, let me go over the steps first. Okay. So what are the steps to carry out this process right here, this rule for determining if something is an absolute maximum? So the steps, I'm going to call it CVS, okay? Critical values, endpoints, and then your sign chart. That's how you find the absolute maximum or even absolute extrema, okay? You always want to find your critical values, determine your endpoints, and then you use your sign charts to determine the behavior of the function around those values. Okay, so let's go ahead and break down what this means. Step numero uno, step one, you have to find the critical values. Critical values. What are the critical values? These are where the derivative is equal to 0 or does not exist. So in this case, we're looking at y of t. So where y prime is equal to 0 or y prime does not exist. Remember, y prime is the velocity, okay? So this can be written as where v is equal to 0 or v dne. Step 2, after finding your critical values, you have to identify your endpoints. Identify your endpoints. In this case, we have only a left endpoint, namely 0, because we're looking at t greater than or equal to 0. So we have a point there, and we're heading to infinity in the right direction, okay, for time. So we're going to have one endpoint. And then after finding those values, these will give us our potential extrema, okay? But the sign chart will help us to determine what they are and if they're the global or just relative. So you use your sign chart comparison. Okay, now let's go ahead and get started. Let's start by finding out the critical values. So critical values, this is where y prime is equal to 0 or dne. So we know that the function, the original function f of t is equal to y of t. So the derivative f prime, the derivative of y prime of t, is going to be our velocity function. So whenever you're looking for, sorry, take that out. Whenever you're looking for the critical values of a function, you differentiate the function and you set it equal to 0. Okay, so this is the derivative. Y prime of t is going to be v of t. So we're basically going to solve for where the velocity is equal to 0. Okay, because at that point the function is neither increasing nor decreasing. Okay, so we know that v of t is 1 minus the arctan of e to the t equals 0. Okay, since this is a calculator section, we can use our calculators to solve this equation, no problem, okay? So to do it, we're going to go to algebra F2 and we're going to solve where v of t is equal to 0. So call up v of t. We already have it stored in our calculator, so we don't have to bother typing in this long expression again. So solve v of t equal to 0. What are you solving for? Comma, you're solving for t. Close that, pound diamond enter, t is equal to 0.4430. Okay, so 0.4430. If you solve this, you end up with t is equal to 0.4430. Now, if you wanted to do this by hand, let me show you how to do this by hand real quick. So to do this by hand, which is not necessary if you're using a calculator, you subtract 1 from both sides, and they have negative arctan of e to the t equals -1, and then you divide both sides by -1, and that yields, what does that give us? Arctan of e to the t equals positive 1. And then to get rid of arctan, you take the tan of both sides. So you take the tan of arctan of e to the t equals the tan of 1. Okay, on the left side, tan and arctan divide out. And you're left with e to the t equals tan of 1. And then to get t by itself, you take the natural logarithm of both sides. So the natural logarithm of e to the t equals the natural logarithm of tan 1. All right. Now, on the left side, the logarithm and e cancel out, so you're left with t. And then you just enter the natural logarithm of tan 1 in your calculator. We already know what the answer is. I'm just showing you how to do it by hand. Okay, so natural logarithm of tan 1. Pound enter to get the approximate result, and we see we got the same thing. Okay, so if we use a calculator solving computer algebra solving program, we can get that done really fast. Okay, so 0.4430. Okay, so we have a critical point. This function right here, 1 minus 10 arctan e to the t, this function doesn't have any value that's going to make it undefined. You don't have any denominator function. And the arctan function, we know the range of this. It doesn't have any discontinuities. Unlike the tan function, the arctan function is just something like this. You don't have any discontinuities there. So bottom line is that we have only one critical value. That's where that function is equal to 0. Okay? So we have found our critical value. Let's write it down. So critical value is t equals 0.443. What are endpoints? Endpoint, we have only one, which is basically t equal to 0. All right, so let's go ahead and we're done with parts 1 and 2 of our steps. We've done the critical values and we've identified our endpoints. Now let's make our sign chart, okay? So our sign chart starts from 0 and tends towards infinity. So we graph 0 and we graph the critical value, okay, 0.443. Now we're going to make our sign chart. We have two intervals. This is interval number 1 and interval 2. All right. So what is this chart going to help us to do? Well, we're going to use the sign of v to tell us the behavior of v prime. Okay, so that's what you want to keep in mind. Use sign of v to tell us the behavior of v prime. So let's put the sign of v on top, and then we'll use that to determine the behavior of the behavior of y of t. Okay. All right. Now let's see. What number do we want to pick between 0 and 4.443? So we can pick 0.2. So we're gonna test t equals 2. All right, so let's put let me get organized here. So let's put here test. Okay, so we're going to test interval 1 with t equals something between 0 and 0.44. Okay, I said 0.2. V of 0.2. What we care about is just the sign. Okay, we don't really care about the value. So let's go to our calculators. What is v of 0.2? So v of 0.2. Diamond enter. It's positive. Okay, v of 0.2 is greater than 0. So on this interval, the velocity is positive. And then how about 0.443? So remember, we already did v of 2 before, right? What was it? It was negative, right? See right here, v of a value bigger than 0.2, let's say v of 2, it's negative. See? Okay. So the other test value we're using is for the second interval. Change color here. The second interval, we wanted to pick t equals 2. We want to examine the sign of the velocity. So velocity here is negative, so it's less than 0. Okay. So positive here, negative here. So what does that tell us about the behavior of y of t? It tells us that the function y of t is increasing from 0 and starts to decrease from that critical value. So that automatically tells us that since it's increasing from 0, this is going to be a local minimum. And this right here, we can conclude that is going to be our local max. Is our local max. Let me write it. So this value here is our local max. Can we conclude that this is our absolute maximum also? Certainly, because it increases to that point, and after that, it decreases forever. So this is our local max and is also our absolute maximum because we do not have any endpoints or critical values that is a maximum on this entire domain. Okay? All right, so in this problem, we can't just write, oh, you know what, t equals 0.443, that's where the maximum value or the absolute maximum is. We have to provide a justification. So we have to basically put our answer in the context of the explanation that we got, okay? So first of all, what can we deduce from this graph right here? V of t, so since, change the color, since V of t changes from positive to negative at t equals 0.443, there is what do we have here? There is a local local maximum here, okay? So if a function so there's a local maximum here. So the function has a change, the derivative of a function changes from positive to negative around the point. That makes it a local maximum. That does not make it the absolute, okay? So we're just acknowledging the fact that this change in sign, first of all, enables us to conclude that we have a local maximum at this point. All right, and then we have to also acknowledge what's occurring at the endpoints. We have only one endpoint here. So since y of t increases from t equals 0, making it a local max, and t equals 0.443 being what? The only critical value, being the only critical value. So if the only critical value is the local maximum right here, and the endpoint is a local mean, then we can automatically conclude that then y of t has an absolute maximum. It's no longer a local, it has an absolute maximum at t equals 0.443. Okay, we don't have any other values of t challenging this critical value right here. The only one that could compete is t equals 0, but it's a local mean. Oh, well, so I'm sorry. So let me make a change here, making it a local min. So this conclusion that we arrived at right here, if you pick a point and after that point you're heading upwards, what does that make that point? It makes it a local mean, okay? So that's why I'm claiming that t equals 0 is a local mean and is nothing compared to this because this is a actually a local max, okay? So this local max is the only maximum that automatically makes it the absolute maximum of the function on the specified domain, okay? All right, so this is a 3-point problem. To earn your 3 points, first of all, you have to set the velocity equal to 0. Just by setting this equation equal to 0 to find your critical points, you earn 1 point. And then if you acknowledge that this value right here, t equals 0.443, is a candidate for determination of the maximum, so like stating critical points and endpoints here, you earn another point just by acknowledging this value as something to consider. And then lastly, stating that it's an absolute maximum, and with your justification basically indicating that it changes from increasing to decreasing, and that's the only local maximum since the endpoint is a local min. Then we have an absolute maximum. All this justification here will earn you another point, total of 3 points for this problem. All right, let's take a look at number 3D. It says find the position of the particle at time t equals 2. Is the particle moving forward, moving toward the origin, or away from the origin at time t equals 2? Justify your answer. So we have a lot of questions here. So let's start by finding the position of the particle at t equals 2. Okay, so this is a formula that you should be familiar with. Fundamental theorem of calculus part 1, x of b minus x of a equals the integral from a to b of the derivative of the position, which is v of t dt. This is for side-to-side movement along the x-axis. If we adapt it to the scenario under consideration, we're going to change our x's to what? Y's. Okay, everything else stays the same. A to b of v of t dt. This is for vertical movement, and then this is for horizontal movement. All right, so this is the formula we're going to be using. So in this problem, what we're going to be doing is we have an interval. Okay, the interval is from 0 to 2. So that makes this our A, and that makes this our B. So what we're looking for is we're to find y of 2, the position at y equals 2, using the initial condition that was provided at the beginning of the problem, which is that the position at y of 0 is equal to 1. Okay? Now, some might wonder, why aren't we using absolute value here? Absolute value applies to total distance covered. Okay? Now, that's totally different. When you have total distance covered, that's when you take the absolute value of the integral of the velocity. But when you're looking for position, this is a formula that you use. All right? So let's go ahead and set it up using this formula right here. We have y of 2 minus y of 0 is equal to the integral from 0 to 2 of your velocity function v of t dt. All right, and then y of 2 is, we can add y of 0 to both sides, right? Is equal to y of 0 plus integral from 0 to 2 of v of t dt. So what is y of 0? We already know what that is, right? So y of 0 is 1 plus this integral right here. So we're going to have our calculator do the work for us. Okay, just a real quick correction. Y of 0 is actually -1. That's what it is. So y of 0 is -1, so this is supposed to be -1. All right, sorry about that. Okay, so y of 0 is -1. That's what's provided for us in the original problem. Now, to calculate the position, we're going to compute -1 plus the integral of our velocity function. We don't have to type it in again since we already have it saved. V of t. The variable we're integrating with respect to, the dummy variable is t. Lower limit of integration is 0, upper limit is 2. Close that. And then press Diamond Enter for your numerical approximation of the position. Bam, negative 1.3607. Negative 1.3607. Okay? Now that's the first part. The second part is the particle moving toward the origin or away from the origin at times t equals 0. So we can give ourselves a visual here to help us answer this question. So let's say you have your y-axis. And then what's happening with the particle is that it's going up and down, okay? So at times t equals 2, the position is negative 1.36. So let's say this is 1, 2, negative 1, negative 2. So negative 1.36 is right here. So the particle is beneath the origin, okay? So this is the deal. Since you're beneath the origin, if your velocity is positive, you're going to be heading towards the origin, okay? So you go in this direction if v is greater than 0, all right? If the velocity is less than 0, guess what? You're going to be heading away from the origin. So two conditions to determine the movement of the particle relative to the origin is the sign of the position and the sign of the velocity, okay? So we already know that y of 2 is equal to, is negative, so y of 2 is less than 0. What we need now is v of 2. What is the velocity at t equals 2? Well, we already found that before, right? In part B, v of 2 is negative, so velocity is negative. So if you're beneath the origin and your velocity is negative, that means you're going to be going downwards beneath the y-axis. So are you moving towards or away from the origin? This is what dominates right here. So what's going to happen is that it's going to be moving away from the origin. Okay, so let's write down our answer. The particle is moving away from the origin. Now, we are also asked to justify, okay? Why? Well, it's moving away from the origin because the position is negative, which means it's less than, is beneath the origin, and the velocity is also negative, which means it's moving downwards away from the origin. Okay, so that's sufficient. So this is a 4-point problem. You get your first point by setting up just by writing this piece right here, the integral, okay, from 0 to 2 of v of t dt. This piece will earn you 1 point. Change my color. So this will earn you 1 point. And then when you use the initial condition, the one that I messed up, y of 0 equals negative 1. Actually, just introducing this piece right here and putting it right here, you earn another 1 point by using the initial condition. A lot of students forget that part. That's really important. And then getting this value, the final answer for the position, you earn another point. And then lastly, saying the movement, describing the movement of the particle relative to the origin and providing justification will earn you your final points. This question, you get a total of 4 points. Okay, so that's that. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the AP Calc exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we just covered in this presentation or any AP Calc concepts in general, just place your questions in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.